I come back to you with this second webinar for myself regarding the commissioning for our controllers, Cybelec and VisiTouch. So previously, we had the first webinar about the Cybelec range controller and the configurator. This is a little tool we used to define which controller suits the machine the best. It's an online tool. Then my colleague did a webinar on Cybelec for press, brake, and shears, hardware programming, introduction to parameters. And then we had a webinar for Cybelec 15, PSWin, and VisiTouch. So today we will see how to set up the machine parameters, including the wizards, which are auto tunings for the axis, and how to set up the beam. I will mostly show you the software for this webinar, which is the VisiTouch offline software. It's the same software as on VisiTouch controllers, and it can be installed if necessary on your computers. We give free of charge license for technicians or commercial marketing. And this software lets you simulate the whole machine, so all the axes can move and the beam as well. So we have a little button to press the pedal down, pedal up. You can press start, the axis will go in position, etc. So it's a useful tool, not only to create parts offline, but as well to simulate and to see how to configure the machine if you don't have a machine in front of you, or if the end user is calling you and he asks questions about the software, then you can simply open this offline software and troubleshoot or simply understand the customer point of view and answer his questions. So the wizard for the electrical axis and the beam wizard that I will show you today is common for Cybelec and VisiTouch. I will show you on VisiTouch software, but it's the same parameters on the Cybelec range controller. And then if you are interested, you can register to the next webinars. Every 2 weeks, we have one webinar. The next one will be about the new functionalities that we recently implemented, as well as different plugins. And then we'll go into 3D with VisiTouch MX, how to program a part and what to take care, what's the specific, how it works, and then the 3D parameterizing, machine modeling, how to create a machine model in our 3D software. All right, let's get into this subject. So as an example, I will configure this machine. We have 1 hour now together, so I will not be able to go into each detail of the machine, but I will show you the main feature, the main guidelines in order to start up a machine. So this is a machine that has Y1, Y2, those are 2 hydraulical axes. Then we have the gauge that you can see here better. So we have 1 X that will move this whole bar front and back, 1 R for up and down, and both the fingers are motorized with Z1, Z2. We also have 1 bending assistance, which is 1 H axis for up and down movement, and 1 A axis that is a rotative axis. So during the bend, we follow the metal sheet bending when this bending assistant will support the metal sheet. So it will go up, it will follow here and in the angular, and this one will also go up slightly during the bend. So we will configure this machine together. The controller for this machine will be a VisiTouch pack, 8 axes, and MVA AA8. So MVA is this little module that has I/O, digital, analog, and the encoder feedback here. And the VisiTouch pack is the main controller with the CPU that has the software. And the HMI for the customer. So now I show you the main software, that is this one. So this is VisiTouch main offline software. So what do we need to do when we start up the machine? We need first to select the axis and map the axis. So we'll go to the machine parameters. By default, the password is 333. You can change it if you want, or if you don't want to. Since this password is known, you can change it. Ask us, email us if you want more detail about this. Then we go to the machine config. First page and second A page. This is our access configuration. So we need to define how many access the machine has. Per default, we have 4 access on our machine, but then if you have more access, you need to program them. So on our machine, we have one Z back. That's we can call Z1. That's an example. You can call it as you want. We have another Z back that will be Z2. And then we have one A front in our case. So A front is rotative bending edge axis. So it's A is the bending assistant axis, and front or back, it's depending on the die, if it's before or after the basically the lower beam or the die. So here I will name it A1, and we also have one H, which is a support axe that is in the front. So H1. This is the icon that will be shown on the bending page. So this is all good. And for the Z2, since it's the right back gauge, I will just change it to the right back gauge. Once I have mapped those axes, my electrical axis, I'll need to restart the software. And I will then define my axis type. This second page, axis dependencies, is mostly when you have a lot of axes and you have groups of axes. One group will be one finger. So let's say you have X1, X2, R1, R2, Z1, Z2. Then you'll have here X1, Z1, R1, all in one group, because it's all linked to one gauge. Here, as I don't have X2 and R2, it does not show on my axis dependencies. What is interesting here is also the bending assistant axis. So we have H1, A1. We can click on the little plus, and we have to define the mechanical binding between those two axes. So this is one option, A rotation, but here we can select different options. HA rotation, so we have one H axis that will lower or higher this whole part that can rotate. Then we have simplified with here one axis that can actually move up and down. We have swing, it goes as well up and down, but here it can it will swing. This point is not fixed, so it will move. We have parallel and crossed. So those are the current bending assistants available. And in our example, we use this one, which is one rotative axis A and one H axis for the support up and down. And we need to define this length L1 and L3. So this is from the middle of the machine and L3. Once we have defined those parameters, the way to start up those axes is like any other electrical axis, which means we have the wizard and we need to follow each steps. All good for this page. We can go to the next one. Here, this is the screen layout page, which means how we will see the screen on the bend numerical page. So X, R, currently, if I go back, I have here X and R. This is my numerical page, and this is how I see my axes. If I go back to my machine parameters, then I will add the axis that I've previously programmed, Z1, Z2, and A1, H1. And now if I go back to my page, I'll be able to see them here. We have two bend num page. This is the first one that is displayed. And if you have a lot of axes, you can also define here your axis on the second page. Let's say I define my bending existence on the second page. Then they will not appear here, and the user needs to swipe on the right or the left in order to see the second page. So that's up to you how you want to show your axis, or if you have too many axes, then you'll need to use this feature. Bend info, this is also the axis, how they appear in the bend info tab. The bend info tab is this little tab here, and this is the configuration of the axis. So you can customize here which axis you want to show. If you want to show only XR like that, or if you want to show Z1, Z2, or maybe here you want to show the main axis and here the bending assistant axis. So this is, you can customize this as needed. And the goal of this little tab is to see all the machine parameters, all the bending parameters in one page with the main program, which means you can open here. Those are the bending parameters that you will also find here. Strictly the same. So if I enable the retraction, I go here, the retraction here will be also set. Like if I disable it here, it will also be disabled here. So it's the same button, but in order to have everything in one page, we have also added them here. So this can be customized with this bend info. And as here we have 2 pages, but here we can have 3, which means we could have Z1, Z2, and here A1, H1. And first we see the first axis, then we can swipe, we see Z1, Z2, swipe again, and the second axis, or everything in one page. Since we have enough space, we can see everything. This can be customized as needed. So that's strictly how they appear on your page. And then we can go into the tuning of the axis and beam. First, we need to define those axes, how they are managed. What's the axis type? Is it, how do we drive those axes? So we have to go to the axis settings. First, we have X, but if you click, you have those same parameters for all the axes. They will be different, of course, because they will depend on your axis. And then first thing to do would be to define the axis type. We have different type of axis type. The most common one will be enable plus or minus 10 volt. It means we drive the axis with one enable output, 24 volt output, and plus or minus 10 volt. If we give minus 10 volt, it will go in negative, plus 10 in positive direction. So we can, and then we have different type depending on the drive. It's mostly depending on your drive or on the motor, which if you have a frequency converter, if you have a 2-speed motor, for example, this is positive, negative, and high speed. This is simply 3 outputs, digital outputs, and this is used for 2-speed motors. So we can use the axis type, whichever on whichever kind of axis we have. So this needs to be defined first before we map the input output, because this will influence what input output are available. So for each axis, you can define the enable plus or minus 10 volt or other type of management. This is what I will use. Then we have to map the input output. So we need to go to IO config. And as you can see, there are not that many input output here because we are on a VisiTouch pack. And X2 is the connector that is behind the controller. So you have the main HMI and you have X2, which are only input output used normally for specific buttons on the screen itself, but not normally used for machine regulation. And here we can add the MVA. So this MVA little module, it has different cards inside, and we will need to configure it on the VisiTouch HMI. So I'll go to next page. IO configuration on CanOpen. I'll need to add one node. So you can add a drive if you have a CanOpen drive, but here we will add a MVA, which is our little module that we will use for input output. We click on enable, and we have to create the MVA depending on which MVA we have. This one is AA8. So it has one analog full card and access card. So here you have analog full card, one access card, second and third access card. That's why I need to define it here. And then if you have another type of MVA, you can as well program more cards, but this will be for bigger MVA. So in this case, in our case, this is how we program it. You can leave the communication to this. This is the default communication parameters. It's using CanOpen. We communicate with MVA in CanOpen. So there is a bus number, a node, an address for the node, and the speed. Per default, the MVA is configured like that. So if you leave this parameter and you plug in the MVA, it will communicate. And then since we added different card, then we can map all those are empty input outputs that we can map on the controller. So I will not map all of them today. I will just show you one example. So on the analog card, here we have 4 outputs, analog outputs, 4 analog inputs. So let's say the beam is managed with an analog output -10 to +10 volts. Then we will need to select Y1 speed set point and Y2 speed set point. This is the analog ±10 volts to define the speed of the beam. And then for the pressure, we can use pressure analog pressure output, sorry, which is 0 to 10 volt. Or in this case, we also have this P and C. Those are 2 current outputs. This means that the output will be wired directly on the coil, on the valve, and it will provide a current. If I map it here, it will be a voltage output, 0 to 10 volts. So this is up to you how your machine is. If you already have an amplifier for the pressure, then you can use the voltage output. And if you do not have, you want to wire directly the current output, you can map it here. That will be for the beam, and Since we have linear encoder on the beam, we need to tell also the controller where the linear encoder, where the encoder input is. So we have to select here E.1.1. This is the input that is here and here, the encoder inputs. So we need to say this is the position of my y1 axis, and this is the position of y2. And for the electrical axis, this is going to be similar. We have 8 digital outputs and 8 digital inputs. So in order to drive my axis, I will need to map the enable signal. Let's map enable for X and enable for R. And then I have plus or minus 10 volts, so I need to set up the X speed set point and R speed set point. This is the analog output. And then we have the encoder input, X and R. So this is one example of configuration for 2 electrical axes. Then you can do the same for Z1, Z2, and on the last card for A and H axis. Then all the output and input can be used for the beam cycle or for the machine cycle. For example, the safety speed, for the pedal, for the go to TDC input, and so on. You can map all the input output as needed. After we've mapped this, we need to restart, and now they will appear and they will work on the controller. Now we can jump into the axis wizard. What we call wizard. So we need to go to the axis page, axis setting, and select the electrical on to startup, and we will go to click on the magic stick, and then we arrive on those green screens which are the wizard. Those are steps. So we have a different step. This is step 1. Those are steps that will guide you through the startup of the machine. You simply need to follow the step and answer the question that the wizard is asking. And then it will help you to troubleshoot, to start up the press brake and to troubleshoot any problem. So this way of starting up the axis is exactly the same on SipTouch, range controller for shear, for press brake, and for VisiTouch as well. So use the plus and minus keys to move axis. So here we will move the axis in either positive or negative direction with an output voltage of 1 volt. I advise to start with a low voltage, not 10 volt, because when we press plus, we don't know exactly in which direction it will go. We know in which direction it should go, but if there is any wiring issue or drive issue or motor issue, something else could happen. So this is my die, just to show the front of the machine, and this is my back gauge. When I press plus, the 0 is here. So I press plus, the gauge should go away from the die, and I press minus, the gauge should go towards the die. So if my gauge is about here, what I will do is press plus to see if it goes away. So I press plus, and here we see that in green, we have the enable for X-axis. This is the enable output, the 24 volt output that the controller is sending. And encoder counting, it is flashing. It means we see that something is counting. That means already that the axis is moving, so that's a good thing, and that we get the information that it's counting. Since we have seen that it's counting, it will give this possibility to press on those buttons, because before they were grayed, so we could not press them. And we need to answer the question, did the axis physically move in the right direction? So again, press plus, it should go in plus away from the die. If I say yes and go to the next step, then we go to the next step. If I say no, it will invert. Well, it depends. If the gauge, when I press plus, went away from the die, then that's okay. It will not change anything. We can go to the next step. If when I press plus, the gauge went towards the die, then it's moving in the wrong direction. So the software will invert the moving direction. And also, possibly it can also invert the counting direction. So this is as you want. It also means something is inverted in your wiring. So you can, by pressing plus and minus, you can either change the wiring or change the setting. Let the controller change its settings so it works in the correct way. Because here it also, when you press plus and minus, it's also recording all the impulse. So it knows that when you press plus, it should go, the value should increase from, let's say, 100 to 200. And if you answer yes, it means it moved in the correct direction, but the controller saw that the counting decreased, then controller knows that the X moved in the correct direction, but the encoder is inverted, which means that it got the wrong information, it decreased. So at that point, it will also invert the counting direction. And if it does, it will let you know. So I press plus, let's say it's moving in the right direction, then I say yes, and I go to the next step. Next step is to define the resolution of the axis, how many impulse we have per millimeter. This will depend on your encoder resolution and on your mechanical gauge as well. So if you know it, just write yes and enter it. 500 impulse per millimeter, press no to go to the next step. If you press, press the green mark to go to the next step. If you don't know it, press no, and it will guide you to define, to measure this resolution. So here it will ask us to move the axis near the minimum limits, measure, and enter the mechanical position. So we will press minus and bring the axis near the die. So we press minus then until the gauge is near a point that we can precisely measure. This is an example here. I set a die here. This is an example. If the die is centered, then we can measure this value in between with this little with this tool here, and we can add the half of the die. That's one way to measure it. Then we can enter. So I will press minus. The gauge is moving towards the die. I measure the value, and let's say I have about 20 millimeter. In this case, maybe even 30 millimeter. And I go to the next page. Then it asks us move axis near the maximum limits, measure and enter the mechanical position. I press plus, the gauge will go away from the die. And once it's away, then we can measure this value. So that is a bit tricky because if it's too far away, it will be hard to measure. So maybe if you have a very long range, maybe move it half range. But the longer the range, the more precise the measure will be. So move axis near the maximum limits, measure and enter the mechanical position. So we move it away until, let's say in my case, my machine is maximum 500 millimeter deep. So I go to 500. And when I press plus, it will calculate the resolution. How it did that? The controller measured between the minimum and the maximum position, it measured the number of oscillation, how many impulse it got. And then by measuring the minimum and maximum position, we told the controller the distance it ran. And with those two parameters, it can know how many impulse per millimeter we have. So we click here, and we will have here, in our case, we have a warning because we have detected the resolution is lower than 200 impulse per millimeter. And in our case, if we want to guarantee a position at 0.01 millimeter, we must have a resolution of 200 impulse per millimeter or more. So that's just a warning. In our case, it calculated 139.95 impulse per millimeter. So that's how we can easily measure the resolution. Okay, and then the idea here is to measure to double check the resolution, which means by pressing plus, now we can see the actual value, and we can bring it half range of the machine in order to check that we have the correct resolution. So let's say we go to about 150 and we measure. Do we have 150? Yes, then we are good. Our resolution is correct. If we have 170, then something went wrong during the wizard at the previous resolution calculation, and we need to do it again. So we go back here and we measure again min, max, and we let the controller calculates. Maybe it's also that we have an issue with the encoder feedback and we miss some impulse or something like that. It could be also a hardware issue as well. The goal of this page is to simply test and to confirm the resolution is correct. Once this is done, we can go to the next page. Here we will teach the minimum and maximum limit, which means we will bring the axis in always manual mode to the minimum limit. If you have a switch, then you can put the very low speed and go on the switch, check that the switch is active and is stopping the movement. Activate the switch if you don't want to break anything. And then you can teach the value. You can go a bit before the switch. Let's say this is my switch value. I can go a bit before, and by clicking here, I can press this teach button. This teach button will teach the current position of the back gauge, and it will teach it here. So now I copy this value directly here. Or if you know your minimum limit, you can say my minimum limit is 5 and simply write it down. Then move axis to the maximum limit and teach. You can do the same for the maximum limit. So you press plus, go to the maximum switch and teach, and then go slightly before. So we set the software limit before the real, the hard switch limit, and we teach this limit. And again, if you know this limit, then simply write it down. Let's say 850. This is the limit. I know my machine. I've designed the machine, so I know this is the limit, and you're good to go. You can go to the next step. Axis setting identification. This is the last step, step 6. Well, almost the last step. In here, we will do what we call an auto tuning, which is the controller will calculate the speed, the acceleration, the gains, the offset, in order to correctly regulate the axis. And to define this test, we need here first to set the testing parameters. We have the direction, SP for positive direction. We have the voltage, 2 volts, and the time, 1 second. I advise to start with low values. And when we press start, the axis will go in positive direction. And it will go one way with maximum 2 volts, 1 second, and then it will come back to its position, and it will do a few movements. This movement, during this movement, it will calculate all the parameters, the gain, the speed, the acceleration, and so on, in order to correctly regulate the axis. So in order to be careful here, I would advise to move the axis more or less in the middle of the machine, of the range. Let's say I have a range from 0 to 800. Then I will move the axis more or less in the middle. Let's say, okay, 350 is enough, since I will go in positive direction. And when I press start, it will go in positive, come back to this value, then do a different movement, and so on. So I will do it. You can see here the real position of the axis. So it went to 360. So it only traveled about 10, 20 millimeters. So that was a very small travel, but in order to be safe, I advise to start with low values. And then you can start to increase these values here, maybe forward to 2 seconds or 3 seconds, and press start again. And you'll see the axe will move more. Because if you move too little, then the calculated parameters will not be as good as if you have a good range of movement. So I can show you how it does on the control on the back gauge. So it first go to this point, and then it will come back to its position. Then it will move, it will shake, so it will make a little noise because it checks different parameters, and then it will stop for a while before testing the acceleration, before it comes back in the beginning quickly and then slowly. When it goes back, it stops here for a while because it calculates the offset. It checks that the gauge, how many millivolts the controller needs to apply for the gauge not to move. And then it gives an acceleration in order to define the maximum acceleration of the back gauge. So we get one movement like that for the x-axis. At the end of this, it will say identification, okay. Or if he couldn't identificate the gain, it will say fail, and it will give you the reason why it failed. Maybe the movement was too small, or maybe something is wrong as well. In our case, sometimes we see that some encoder have wrong, and we don't see it doesn't count correctly. So we also see it here. So we can see different issues also on this wizard, but normally we should have identified all the issues in previous wizard. We have one new parameter, which is the wizard sensibility. Per default 80%. We have noticed that on new machines, sometimes the calculated speed, acceleration are too high. Which means that after we make a movement, the calculate values are slightly too high. So per default, we decrease the calculated values of 80%. So if you find that it's too slow, you can put it back to 100%. Or if you retrofit the machine and the mechanical, the drive, the motor is old, then you can lower this value. So it will calculate slightly lower values. Then we can go to the last step, which is the fine tuning. In this case, we will make different movement, and we will check that the back gauge is precise, that it goes from 100 to 500 without any error, and that we can move also with very small values, 0.1, 0.001 millimeter, and so on. So here we can move 100%, we'll move it at 93.99 millimeter per second. So I can move it manually first, and then positive, negative, and then I can move it in automatic mode. So I have to define here a value and press start. Just one information, when I move it manually, it will move it with the manual speed, 23.50 millimeter per second. And when I move it in automatic mode, it will use the positioning speed, 93.99. So this speed is applied when I press on start. And here, the goal is to make big movement from minimum to maximum value in order to detect if there are any errors. And then small movement here, 0.1, in order to see how precise we can be and if it's overshooting or not. So after we have done this, the axis is set up. There is no more test to do, and we are good to go. We can go to the next axis and go to the next configuration. There are three safety parameters that you can also fine tune. You can go to this advanced page, and here we have supervisor error, speed level, and control timeout. Those are three safety parameters that if the real axis is not following its trajectory, so the trajectory is the theoretical trajectory we try to reach, and the real measurements will be a bit normally slightly below that, or are the same at least. If we have too much difference between those two trajectory, it means the axis is not following its target as it should. And then it will give an error 32, error 33, or 39. And each of these error, I will let you check the parameter manual is explained, and it's also explained what these parameter are, why the axis was stopped, by which parameter it was stopped. This is the following error. This is the following error, but in speed, and this is the control timeout. If after 0.4 seconds, we give the order to move and the axis is still not moving, then we try to move. So this can be adapted, slightly increase if you have too many errors, following errors, but I advise to cancel them because they are safety. If you have mechanical issue in your gauge and you cancel those parameters, then the gauge will start to move forever and will never stop to move. So I advise to keep those parameters. And if you get this error 32, 33, or 39, check out the parameter manual. It will tell you error 32. It's because this is slightly too low. Or it could be also possible that your positioning speed is slightly too high. So you can try first to slightly decrease this parameter. And here maybe increase a little bit the following supervisor error. All right, that's it for the axis wizard. This is similar for all axes, including the bending assistance. So the bending assistance, you will also need to follow this wizard and start up the axis like that. Now for the beam. So I go to the beam and I have my min-max to right and the nominal speed to right. This is the theoretical speed the beam can go. Then I can click on the wizard and I can define those parameters. Those are the fundamental parameters, which is the encoder resolution, min-max limit, maximum limit between Y1 and Y2, the valve type, 0 to 3. So you have if you have different hydraulic, select 0, 1, 2, or for all hydraulic, we have type 3. It's also clearly explained in the manual, for which exactly type it is. So I'll let you check this. And we have the speed of the machine. High speed up, down, low speed up and down. In the wizard, we will actually calculate those speed so they might be changed afterwards. Step 2, this is to check that your beam is correctly wired and the hydraulic part is working correctly. So we will here move the beam with always the pedal down, and it will move the beam always in low speed. So with SN active. And here we are in not regulated mode. It means we simply apply 3 volts on the proportional valve and 2 volts on the pressure. First here, you need to define, since we have not indexed the beam, you need to define the real axis position. So you need to measure Y1, Y2, and here teach those values. Let's say 250 here and 250 here. You press the pedal down, and the beam needs to go down and the counting needs to decrease. If that's not the case, you can change the counting direction, yes, or the output and change the moving direction. So here I advise to start with a low voltage, press the down pedal, it should move just a little bit, and it will let you know if the beam, if Y1, Y2 is moving in the correct direction, and if it's counting in the correct direction. In this case, we move Y1, Y2, and here we only move Y1 and only move Y2. This is all down movement. If we want to go up, we have to invert the arrow. Just check the parameter that will change depending if you are in up and down. And here we will apply, let's say, 1 volt on the proportional valve and 4 volt on the pressure. We will probably need more pressure because we need to lift the beam up, so we need more pressure to do that. And then we press the down pedal always, except here we invert the voltage on the proportional valve in order to go the opposite direction. And here the beam will go up. Note that since we are not in regulated mode, we apply 1 volt on Y1, Y2, and therefore the beam will not act the same, so we will maybe start to go out of synchronize slightly. Then the second test you can do is switch to regulated mode, and here you see this value becomes millimeter per second instead. It means we will switch to millimeter per second here, and we will regulate the beam. We will synchronize both values. So this page is simply to check that it's moving and counting in the correct direction. And then if your beam is not straight, you can use this page as well to straighten the beam again in that case. Then we can move to step 3. Here you need to plug in a manometer, and you will read the pressure in bars. So here we have 0 to 100%. If you want, you can put in bar and put your maximum, let's say 270 bars. And you will increase by press plus, increase the pressure. See that the pressure is increasing, and you can define different pressure points. So we increase the pressure until, let's say, we reach 68 bars, this value. And let's say now I read 60, 68. Now I have 68, so I can click here and I will teach the value. I will copy this value here. And so on, you can do the pressure curve. And since the pressure curve is not really linear, you can add more points of measure. All the points in between will be linearly interpolated between 0 to 68 and so on. And if you want, you can switch back to percentage. 0, 25, 50, 75, and 100. So the goal in here is simply to set the pressure curve. Once you're done, you press on stop. It will slowly reduce the pressure. Then we have the first indexing. The idea here is to put the beam on blocks where we precisely know the height So here, that would be 2 blocks, for example. You can use as well tools, but you need to make sure they can withstand some pressure and that you need this value to be very precise. So this value will be your reference on the pressure. It will be here the value that you need to teach. And why we do this? It's because we want to know precisely where the beam is. So we put the beam on the blocks. And then once the beam is detected that it's not moving anymore because it can't go anymore mechanically, it's on the blocks, it's stuck, then it will teach this value on the encoder. And then when it index, it will get the index pulse. So we will see this value that will change. So I will show you here. Once we have reached the blocks, it will stop. So it's simulated here. So it will stop around 0 or 20. And it will display the pop-up reference found and copy the value here to directly on the real Y1, Y2. And when I start to index, it will copy, it will go up, and then when it reaches the index, it will copy this value on the index value. So this whole page goal is simply to find the index Y1, Y2 values. When I press start, it goes up, and then teach this value. That's it for this page to check. If you want, you can cancel here the index by clicking on it and then do against the procedure of the index to simply check that your index is precise, to see if you between two measures you get the same value. Because if you don't get the same value, maybe it's not precise enough. Maybe you need to check the tools or the block that you are using. And so, of course, in this step, we use very low pressure. Here we have 1% pressure. You can put more pressure, but of course, you need your blocks needs to withstand this pressure. So I advise not to use too much pressure, which simply needs the beam to be on the blocks and not have any space. And then we can go to the final step, which is the beam fine tuning. Here we need to define a correct range. This is my TDC, my top dead center. This is the distance in high speed down, distance in low speed down, and calculated bottom dead center. So by pressing the pedal, the beam will go down and will do the cycle. It will go to 50 and then it will go back up to 150. So this is simply to do a tuning. I advise not to put any tool in here because we don't know that there is any tool in this wizard. The goal is simply to move the beam in high speed down, low speed down, and high speed up. So you can press the pedal, you will see high speed down, low speed down. Then it stops at the pinch point for 1 second with 10% of pressure before it goes down, it goes up in low speed up and to 150. Once we are able to do this movement, we can activate the auto tuning and then press the pedal down. The controller will then calculate the offset on the valves, the speed that the beam can reach, the saturation voltage, at which voltage the speed does not increase anymore, and the gain in bottom dead center. So it will stay down, it will do the calculation it needs, then it will go back up. You can press the pedal and you will see here the percentage that is increasing, which means that's how far it goes in the wizard. You have to press a few times, maybe 15 to 20 times. And once you have reached 100%, you can press on the mark and then it will teach the parameters, it will program the parameters. If you simply click here on the cancel on the auto-tune button, it will simply cancel the auto-tune and not overwrite any parameters. So once you have reached 100%, you click here and identified beam parameters are saved. They are saved now, and you can disable the auto-tuning. And then press the pedal down again, do the movements, and you will see the beam movement should be much better after the auto-tuning because it checks different things, the valve opening, the offsets, all the gains, and so on. So after you have done this tuning, you can do it one more time if you want. That's possible. And then the beam behavior should be much better. Then you have the fine tuning. So here we have the whole beam parameters. You have high speed down, speed change, low speed down, after pinch point, final approach, BDC, and so on. So that's the whole movement of the beam. And if you click here, you will see all the parameters of the beam. Of course, we cannot talk about them today, otherwise it will be too long, but that's basically all the parameters. And if then after the auto-tuning, since it does a lot of things, but it cannot unfortunately do everything, you still need sometimes to fine tune. Then let's say you have an issue in low speed down, you go to this page, low speed down, you check the parameters you want to change, you change it, you go back to the magic stick, you press the pedal, see if the problem is solved. If it's solved, then good. If it's not solved, then you go back to the low speed down and change again the parameters, then try to change another parameters. If you have vibration, if you have noise, if you have a loud bong, then you can check in this kind of parameters. So this then is the fine tuning, the final beam tuning. And after step 5, there is no more step. We are good to go. We have set up the beam parameters. Okay, that's it for this beam. I hope I was clear enough. This trading for me is done. That's all I wanted to do. Now, if you have any question, if you want to write anything in the chat, please do, and I will answer your question.